multiplying and dividing them. So, y'all, a rational expression is just a fraction with variables in it. That's all a rational expression is a fraction. So, sometimes they're just variables with numbers, and sometimes they're actual polynomials. So, let's just see some examples. And at first, we're just simplifying them. So, let's just start with like something super easy like 10a over 15a to the third. 10a over 15a to the third. We're starting really simple. So we got a number and a variable. So for your numbers, when you're simplifying a rational expression, you just simplify the fraction. So for the numbers, you just reduce the fraction. So what is 10 over 15 reduced to be?
1 over 2 over 3.
2 over 3. They're both divided by 5. So that's 2 over 3. And back a long time ago when we did exponent rules, if we divided two that had the same base, what did we do to them? We subtract them, and the answer goes to wherever the biggest one was. What's bigger, first power or third power?
Third power.
Third power. So 3 minus 1 is 2. So I'm going to put an a squared on the bottom. Do y'all remember me saying big kid gets the leftovers? I said big kid, don't be ugly. That's right. Big kid gets the leftovers. The a cubed is bigger, so after you subtract them, the leftover goes with that. So that's my simplified answer to number 1. Any questions there? So for numbers, you just reduce the fraction. For your variables, if they're the same, you subtract them on top and bottom, and big kid gets leftovers. Okay? So like if I have this one that's all variables here. There's no numbers, just variables. What does this simplify to be, y'all? What about my A's? What am I going to get on my A's?
2 A. No. 5 A. 1 A. I don't know. Oh.
Well, this is a to the first, right?
Yeah, and we subtract this, that'd be 8 to
Eight
the
to
second. 8 to the second.
A to the second. Does it go on top or bottom?
Top.
Top, because big kid gets leftovers, so the leftovers A squared.
B to the third. Over B to the third.
And B to the third goes where? Top or bottom?
Over B to the third. Yeah.
And now you have different bases, so that's all you can do. So what you do for your variables is you go until they're all different variables.
Add and subtracting letters.
That's right. So there's that. So then they start giving you some polynomials. Like this. And so that big fun F word comes out called factoring. So to simplify rational expressions with polynomials, we want to first factor the polynomials. Now, here's what you cannot do. I'm writing it at the top of the note, so maybe we'll see it. You cannot cancel parts of polynomials. You cannot cancel parts of polynomials. I'm going to highlight that. It's important. So that means I can't just cancel that x squared with the x squared. You cannot cancel parts of polynomials, but you can factor them. I cannot cancel x squared with x squared. Okay, if there's a plus or a minus with your term, you cannot just cancel with them. There was no pluses and minuses with these two problems, so I could reduce them. But you can't do them if there's pluses and minuses. If they're a polynomial, you have to factor. So this is a trinomial, the numerator is. What multiplied to get negative 15 and adds to get negative 2? Negative 5, positive 3, right? So you make yourself two binomials, x minus 5 times x plus 3. And we're going to hang tight for that for a second. And then, see if y'all remember, x squared minus 9 is something we called a difference of squares.
So x plus 9, x minus 9.
You're very close, Katie. What multiplies times itself to get 9? 3 and 3. So it's x plus 3 and x minus 3. Okay? So your first terms are what multiplies times itself to get the x squared. The last one is what multiplies times itself to get the 9. And in the middle of difference of the squares, we put a plus and a minus. Now, we cannot cancel parts of polynomials, but we can cancel entire polynomials. So we can cancel this x plus 3 with this x plus 3. On top of each other, one on top, one on bottom, and they're exactly the same. You can cancel those out. So then we're left with x minus 5 over x minus 3. We can't cancel the x's because they're both attached to a polynomial, so that is my final answer. X minus 5 over x minus 3. So if it's in a polynomial, meaning you see pluses and minuses, factor before you cancel, and you can only cancel the entire polynomial, not pieces of them. All right, next one. X squared minus 8x plus 16 over x squared. Hang on. Plus 10x plus 24. All right, so these are both trinomials. So the first one, what multiplies to get 16 and adds to get negative 8?
4 and -4.
Both negative, though, right? If it multiplies to be a positive, it has to be a negative times a negative, right? Or a positive times a positive. So that one's x minus 4 times x minus 4 over what multiplies to get 24 and adds to get positive 10? Multiplies to get 24, adds to get 10. 6 and 4. All positive. So an x plus 4 and an x plus 6. And that did not work out the way I wanted it to. So this one has nothing that cancels out because they have to be exactly the same. So we can leave it x minus 4 times x minus 4, or rewrite it x minus 4 squared times x plus 4 times x plus 6. So you have done this before if you had me for Algebra 1. Okay, then you've done this before. So that one didn't simplify. I just rewrote it.
Jessica Castillo and Jalen Parker come to the office. Jessica Castillo and Jalen Parker come to the office.
Here's one a little bit simpler. 40x plus 20 over 10x plus 30. Now, we can actually factor these by looking for the GCF. Okay? So both of these are factorable with the GCF. So look at the numerator first. What's the GCF between 40 and 20? Huh?
20.
20. 20 is the largest number that goes into both. So we factor out the 20, and remember we do the reverse distributive property. So what times 20 equals 40x? 2x. Very good. Plus what times 20 equals 20? 1. So there's the numerator all factored out. And then the denominator, same thing. There's a GCF. What's the GCF between 10 and 30?
10.
10. What times 10 is 10x?
1.
Plus what times 10 is 30? 3. Now our polynomials aren't going to cancel out because they're not the same polynomial, right? But these numbers over here can reduce. So if they're not in the parentheses, you can reduce them. And 20 over 10 is 2 over 1. So that means you can put a 2 with the top number. And then you don't have to put anything with the bottom. You can just leave it x plus 3. So that is the most simplified form of that fraction. You guys ready to try one on your own real quick? Try it on your own. If you get stuck, it's okay. I'll help you in a second. But try it. The top is a trinomial. The bottom, you can do a GCF. and see if anything cancels out. Go back and show this. There we go. All right, so did y'all get something that multiplies to get -3 and adds to get -2? Not 2 and 1 because it's got to multiply to get 3. It is 3 and 1. 3's prime, isn't it? 3 is prime, so that means the only thing that multiplies to get 3 is 3 and 1, right? So, but if it adds to be a -2, that means the bigger of those numbers needs to be a negative, right? So it's going to be x minus 3 times x plus 1. Does that make sense to everybody? All right, and then denominator is a GCF. So what's the GCF between 2 and 6? 2. And what comes x minus what? Oh, that's nice because what can cancel out? The x minus 3 with the x minus 3. I'm left with an x plus 1 over 2. That's all we can do. So any questions about that? Well, so far we've only simplified single fractions. So now we got to pull in a second fraction in there and multiply with it. But after we learn to multiply, dividing's easy. So here we go. Multiply rational expressions. And a rational expression is a fraction with variables in it. All right. So when you're multiplying rational expressions, you can cancel. Y'all know what I mean by cancel, like eliminate stuff. You can cancel 2 different ways. You can do it top and bottom. Top with bottom. And you can cancel with diagonals. You cannot cancel side to side. Let me get some space. Sorry, y'all. Not side by side. So you can't cancel sideways. Okay, you can cancel anything on top and bottom or diagonal from each other, but not sideways. Not straight across. So let's first do numbers and variables. Our last example was 5, so this will be 6. 8x to the third y over 2xy squared times 7x to the fourth over. And there's a bunch of different ways you can do this. Some people like to look up and down first and then look diagonal. Okay? Be nice. Okay. So, top and bottom. So if I'm reducing this fraction right here, ignore this fraction. What is 8 over 2 reduced to? 4 over 1. So do your numbers just like a fraction. And these x's are divided, so I subtract them and get what? X squared, top or bottom? Big kid gets leftovers. So x squared on top. And then the y's I subtract and get what? Y to the first on the bottom, right? And then this one don't have anything that reduces, does it? 7 over 4 won't reduce. X and the y won't reduce. So now I can look diagonally. So I can look at this denominator with this numerator. I don't have variables that match up, but what's 4 over 4 reduced to? 1. So they both make a 1. And that's all I can do for that. And then over here, the 1y and the 7x to the fourth, I don't have anything that cancels there. So after you're done canceling everything, top and bottom and diagonally, you multiply what's left across. For my numbers, I have 1 times 7. That equals what? 7. X squared times x to the 4th. When we multiply with the same base, we do what to the exponents? Add them. So x to the 6, and there's no y's on the top, is there? So this is 1 times y times 1 times y. So I've got a 1, but I can leave this off. What's y times y?
Squared.
Y squared. And that goes on the bottom. And then you double check. I have all different bases and no numbers that reduce. So that is my answer. So you can cancel out top and bottom and diagonally, but not side to side. And when you're finished canceling out everything, then you can multiply side to side, but you can't cancel side to side. Number 7. Let's do another one similar, and then we'll do polynomials. 5x squared y to the 3rd over 3x y to the 4th times 7x to the 5th over 15x to the 4th y. So I like to take all the fractions individually and do top and bottom, and then I look diagonal. That way I don't forget anything. So sometimes if I'm like looking all over the place, I get a little confused. So that just gives me a method to my madness. Sometimes it is boring. All right, I'm going to scoot this down so I have room to write on top. Sorry about that. All right, so I'm going to look at this fraction. Does 5 over 3 reduce?
Nope.
What about my x's?
Yep.
I subtract them and get what?
X the first.
Top or bottom?
Back in the top.
So x on top. And
Y
then,
is
and I get what?
back in on the bottom.
What's left?
First.
Y the first on bottom. Are y'all okay with the first fraction? Okay, the next fraction is 27 over 5 reduced. Do they have a number that goes into them besides
No,
1?
27 and 3.
Well, they both go in, 3 goes into both of them, doesn't it? Just look at 27 and 15. They both have a 3 that goes into them, right? I'm not looking diagonal yet. I'm still working on this fraction.
How many times 3 go into 15?
5 times.
I knew that.
Sometimes we forget, right?
Yeah.
This 3 go into both of them? Okay. How many? What's 27 divided by 30? It's 27 divided by 30. Now, if we're not sure, our calculator, if we can type 27 divided by 15 and hit math enter, it'll reduce that fraction for us, won't it? It does. It'll tell us 9/5. And then the x's I subtracted and put my leftover where? On top. Big kids on top, and that's x to the first, right? All right, now let's look diagonal. So I'm going to look at this fraction with the 5x, with down here is a 5y. So what reduces diagonally there?
5 is the 1.
The 5 and 5 will make 1s.
And the 9.
Wait, and then the x and the y won't do anything. So we go this way. The numbers 9 and 3 makes a 1 and a 3. Y'all with me there? And then I have an x and a y, so they're different. So then I multiply across. For my numbers on top, I have 1 times 3 is 3. X times x is what?
X squared.
X squared. On bottom, I have 1y times 1y, which is
Y squared.
Y squared. And I have no like bases, so that is my final answer. So if you have any like bases at the end, then you reduce again. Sometimes it happens. And if your numbers need to be reduced again, reduce again. I personally think it's easier to do it with polynomials than doing those monomial things. So, here we go again with factor. 3x squared minus 3x times x squared plus 4x minus 5 times x squared plus x minus 20 over 3x. Fraction times a fraction. And when I factor mine, y'all, it actually saves you time if you'll just like write it above it or below it. So if you skip a little space between that and the previous problem, it makes.
Is that 3x squared minus 3x?
My writing's ugly. I'm sorry.
Okay, so that's big.
Okay, so I'm gonna factor every piece. I'm gonna factor this one, then this one, then this one, then this one. Okay.
Can you not work that and start like working that breaking it down?
You cannot start canceling anything because you cannot cancel parts of polynomials. You have to cancel an entire polynomial. So if it's a polynomial, you have to factor before you cancel. Okay? So GCF in this group, this one's got a GCF.
3.
3, and they both have an X. So you pick the smallest, and that's 3X. And what times 3X makes 3X squared? X minus what times 3X makes 3X? 1. And then I do the bottom, which is a trinomial. What multiplies to get negative 5 and adds to get positive 4? Mm-hmm.
Yeah.
Try again. It adds to be a negative.
Negative 1 and 5.
Yes. X minus 1 and X plus 5. Because the bigger one needs to be a positive. Right? Y'all are good. Y'all are good. We haven't factored in a long time. We haven't. We've done all kinds of. We did logarithms for crying out loud. Y'all are geniuses now. We can do logarithms. Don't y'all feel so smart doing logarithms? Come on. I haven't even graded y'all's test yet. I know y'all all aced it. Right. In my dreams. Okay. So, this is a 1 right here, right? So, what multiplies to get negative 20 and adds to get a positive 1? Well, we know they're going to have opposite signs because it multiplied to get a negative. Right. And it's going to, the bigger one's positive, so which one does that need to be? 5. So, X minus 4 and X plus 5. And 3X, 5. And 3X down there in the bottom won't factor, so we just leave it 3X. But looky there. I also have a 3X over here, right? And they're diagonal, so we can cancel. Remember, you can cancel top, bottom. Well, whatever. Top, bottom, and diagonal. So, okay, tell me top and bottom will cancel.
I know you can.
What?
The X's.
Which you can't just cancel X's. You got to cancel the whole thing. X plus 5 and X plus 5 are diagonal. And what else? There's one more thing cancels. X minus 1s. Very good. So on top, I'm left with what?
None.
Yeah, I am.
Oh.
X minus 4. On bottom, I'm left with nothing, right? Mm-hmm. So you can say it's over 1, or you can say that's the same thing as X minus 4. You get a whole number, not a fraction. Okay? So if there's polynomials, meaning there's pluses and minuses, you need to factor. Okay. Oh, let's do an easy one.
How much harder would it get to see?
Not much. That's really one of the hardest ones. The hardest ones is when you have to factor all 4 terms. It is. Debbie cake. Okay, now looky here. Y'all think back to elementary school. What did you do when you multiplied a fraction times a whole number? You put the whole number over 1, didn't you? So that's what we're supposed to do. Put that whole number over there over 1. So if one's a fraction, one's not, put the polynomial that's not over 1. Does X plus 2 factor? Is it a difference of squares, or does it have a GCF besides 1? No, GCF is only 1, right? What about X squared minus 9? Is that a difference of squares or a GCF?
No, man.
It ain't GCF. It's a difference of squares, right? So 2 binomials. What times itself is X squared? X. And what times itself is 9?
3.
And it's a plus and a minus, right? Okay. And then that X squared plus 3X plus 9. Well, ain't nothing that... I don't think I copied this right. Let's make this a 6 and it'll work. Sorry, y'all. Change this to 6. I did my notes in a really big hurry today. So what multiplies to get 9 and adds to get 6?
3.
3 and 3. So that's x plus 3 and x plus 3, right? So now I can look up and down in diagonal. Don't forget the x plus 2 that wasn't factorable. And see if anything cancels. Does anything cancel? They have to be exactly the same for polynomials to cancel, remember?
Yeah, no, only half that one. The plus stuff.
Yeah, x plus 3 and x plus 3. And I don't cancel both of them, though, because you have to have one to cancel with each one. Does that make sense? You have to have it
Everybody
twice
has
to cancel
partner.
twice. Yeah, everybody has to have a partner to cancel out. So on top, I'm left with x plus 2 and x plus 3. So make sure you write them in parentheses to keep them separate. And on bottom, what's left?
X minus 3.
X minus 3. Does an x plus 3 cancel with an x minus 3?
Nope.
No, it does not. It's a different polynomial, and we can't cancel parts
You
of
know
it.
that thing whenever you did the plus and the minus?
Difference of squares over here?
So we've got to do difference of squares and
Or GCF for a binomial. If it's trinomial, you do multiply to get the last term, add to get the middle term. Rules of factoring. I want y'all to try one on your very, very own.
I think you ought to give us 4 of them. 4 different of all kinds.
No. Yeah, we got to do divide, but if you can multiply, you can divide. Y'all try that. Well, you only have to factor this side because these two aren't factorable. So there you go. There's another hint. And those are not trinomials, so that means you can either do GCS or difference of squares. Stephen. Stefan or Caleb? No. Don't get me preaching. All right, could y'all factor 2x squared minus 10x?
yes,
By how?
you get 2x.
Uh-huh.
X minus 5.
Yeah, because you had a GCF of 2x, right?
And then that
This-
one you did that plus and minus.
So that's called a what?
You did a parentheses.
What's it called? DOS. Difference of squares. So x plus 5 and x minus 5 there. And nothing else with factor over there. So what cancels? Up and down what?
X minus 5.
X minus 5 with x minus 5. Anything else? What about that? What about 2 and 2?
but no, because that's an x squared, and that was just an x.
Yeah, but it's okay if they're not within a polynomial. They're monomials. So you can cancel parts of monomials, just not polynomials. What about x and x squared, though? Same thing, right? Big kid gets leftovers, right? So x and x squared, subtract them, you get x to the first left, and does that go on top or bottom?
Okay, so
Subtract
you
them.
do away with.
I did away with my twos. Those make ones. Okay? And then the x and x squared, they're divided, so we subtract them and we get x to the first power. It's bigger down there, so you keep it on the bottom. So cancel it there, put an x to the first on bottom. So on top, all we have left is what? Well, the x plus 3, right? And on bottom, we have left a 1x, which is just x, and an x plus 5. Does that make sense? So you can cancel up and down and diagonally, and you can cancel parts of monomials as long as it's not with a plus or a minus. Okay, if they're multiplied together, you can cancel their parts. If they're added and subtracted together, you can't cancel the parts. So the last thing we have to do, you could, and get x squared plus 5x. And the back of the book might do that. It's just simpler if you just leave it all distributed out. Okay. All right. It just saves us a step at the end. So the last thing we have to do is divide rational expressions. Now, y'all, a rational expression is just a fraction. So you treat it like a fraction. And you remember when you divide two fractions, that little thing you learned in junior high called keep, change, flip? Never heard of keep, change? Yeah, you would have. The rest of the county learns keep, change, flip. Have y'all heard of keep, change, flip before for dividing fractions? Well, let's just do it old-fashioned way. Here's a fraction. 3/4 divided by 3/2. So we would keep the first fraction, change it to multiplication, and then multiply by the reciprocal. Right? Does that look familiar? Keep the first fraction, change it to multiplication, flip the second one. Keep, change, flip. Then we'd multiply across and get 6/12 reduced to a half. Or couldn't we cancel these diagonally? Did we learn that little trick too one day? Back in our elementary school years. They both divide by, you could divide diagonally. 3 and 3 are both divisible by 3, so they make ones. 2 and 4 are both divisible by 2. 4 divided by 2 is 2. 2 divided by 2 is 1. Multiply across. 1 times 1 is 1. 2 times. Or you could have multiplied across and then reduced. 3/4 times 2/3. 3 times 2 is 6. 4 times 3 is 12. And 6/12 is a half. Either way.
That's the way I learned it.
Okay. But first, the first thing you do when you divide is to keep it, change it to multiply, use the reciprocal. Right? Same thing with polynomials. So what was our last example number? So this would be 10. So 6a squared b to the third over 2b divided by 5a to the fifth over 10b to the 10th.
Swap that for the second fraction.
So the first thing we do is keep, change, flip. So copy the first fraction. No, first one you keep exactly the way it is. That's why it's called keep. You copy it, change it to multiply, and then do the reciprocal of the second fraction. Keep, change, flip. Keep it, change to multiply, use the reciprocal. Now we do like we did a while ago. We can cancel out up and down and diagonally. So do y'all want to do it fraction at a time? Yeah. And do up and down?
Yeah.
So 6 over 2 reduces to what?
2 over 1.
No, 3 over 1.
Yeah, right.
And there's no A's, and you can subtract the B's and get what?
Kid gets his leftovers.
What is the leftover?
Squared.
B squared on top. We okay with that? All right, now this fraction, 10 over 5 reduces to what? 2 over 1. And the A and B are different bases, so we don't do that. Then you can look diagonally. I didn't put my 1. The 3 and the 1 won't reduce. What about an A squared and A to the 5th? Well, I'll subtract them. And get what?
3.
A to the 3rd, top or bottom?
Bottom pack.
Big kids on bottom. And then that's all for that diagonal. So this way, can't do nothing there. So now you're ready to multiply across. So remember, you multiply your numbers. 3 times 2 is what? 3 times 3 times 2 is 6.
Oh, 6. Oh, hold on.
That's okay. And then you don't have any A's on top, so you look at your B's, and they're multiplied, so you add them and get B to the what? 12. Very good. Over. 1 times 1 is 1. All you have is an A to the 3rd. So that's an A to the 3rd. And there's no like bases left, so that's your final answer. So the only thing different, y'all, in multiplying and dividing is the very first step. Remember, if it's division, you got to do keep, change, flip. Okay? Let's do a couple more. Let's do some with some polynomials. 7x divided by 2x minus 10 divided by x squared minus 6x over x squared minus 11x plus 30. All right, I need y'all to get y'all's head up and pay attention. We got 2 more examples. That's it. 2 more. 2 more today, and then it's homework time, promise. So first thing, if I divide 2 fractions, what do I do first? Keep the first one. Change it to multiply. Reciprocal of the second one, right? So that goes on top of that. Then I see what I can factor. Can I factor 7x? No. Can I factor 2x minus 10?
Yes.
Yeah, it's got a GCF of what? 2. So what times 2 is 2x? And what times 2 is negative 10? Good. And then this one is a trinomial. So what multiplies to get 30 and adds to get negative 11?
5 and 6.
But they're both negative, right? Because a negative times a negative is a positive, and a negative plus a negative is a negative. So x minus 5 times x minus 6. And right here, do I have a GCF?
No, you gotta do that plus and minus thing.
No, it's not difference of squares. GCF is x. Right? They both have an x, don't they?
Well, what are you gonna do?
Well, watch. What times x is x squared?
X.
Minus what times x is 6x? 6. There you go. And if it gets confusing because you have extra stuff, scribble out the ones you factored. And that way you can just look at the binomials and stuff. Now, first of all, diagonally, these x's can cancel, right?
Yep.
What else can I cancel?
Negative 5.
X minus 5 with x minus 5. And then x minus 6 and x minus 6. What am I left with?
7 over 2.
7 over 2. All my polynomials went away. And 7 over 2 won't reduce. It's 3.5. So you can leave it 7 over 2. Questions? Let's do one more together. This will be our last one before we do our homework. Let me give us a little more space. So x squared minus x minus 2 over x squared plus 4x minus 5 divided by x over 5x. Now what do I do first when I divide 2 fractions?
Swap it.
Keep, change, flip, right? So keep the first one. So x squared minus x minus 2 over x squared plus 4x minus 5. Change it to multiply. Flip the second one. Over x minus 2. Okay. And then I try to factor everything. Trinomial. So what multiplies to get -2 and adds to get -1? Yep, x minus 2 and x plus 1, right? Alright, I'll cross that out since I used it. What multiplies to get -5 and adds to get a +4? So x plus 5 and an x minus 1. I know. I was just looking at you. I'm proud of you today. And then right here, we got a GCF of 5, don't we?
We do that little 5x times
5 times what?
5x
X plus
5.
5. Does x minus 2 factor?
No.
I'm going to scribble these out so I don't have all the extra stuff.
Oh, they do with that top one.
It cancels out with it, don't it? Yeah. So I can cancel out x minus 2 with x minus 2. What else?
That x plus 5.
X plus 5 and x plus 5 diagonally.
And then
That's all I can do. They're not the same.
Nope.
So can't do anything else. So on top I have what? A 5 and an x plus 1? Yeah. So make sure you put that 5 there with it. And on bottom, what do I have?
x minus 1.
X minus 1. And I can't cancel the x's and the 1's because I can't cancel parts of polynomials. They have to be exactly the same. And that's all we got. So that's the end of simplifying and multiplying and dividing rational expressions. I hope you enjoyed this lesson brought to you by Miss Isbell in room D13. Have a good day.